Hey there everyone, Erica here from Howie49RC. Welcome back to the Rocket Rustler build, where as a tribute to the Mythbusters JATO rocket car, I am going to be putting rockets on a Rustler and calling it the Rocket Rustler. Yeah, last time we got this thing all cleaned up, got fresh hex head hardware on it, got some new rear tires, fresh grease, rear shocks, all that jazz. Today I have a lot of mill and lathe work ahead of me because I'm going to be making a drivetrain / motor disconnect. Now, what the heck, Erica? What in the world is a drivetrain disconnect? Well, basically, when I ignite the rockets on this thing, I want to be under complete rocket power, no drag from the motor whatsoever. So we're gonna have this sliding, disengaging, engaging thingamadoo-dat. Yeah, let me just show you the drawings real quick. So I've got these two dogged gears from a Traxxas Summit differential assembly. They're for locking and unlocking the differential. They happen to fit very nicely together, and I've had them in the back of my mind for quite a while now, and I think this will be the perfect opportunity to make good use of them. So the first thing that needs to happen is one of these needs to get turned into a pinion for a motor. The way we're going to do that is by making a tube with a flange on it, and then the gear is going to slide onto that tube, stop at the flange, and then there's going to be a collar that then goes over top of that tube also, with two dogs that then align with the two slots here in the gear. I'm calling it a gear, it's not really a gear, you know what I mean. That all is going to get held together with a set screw that is also going to hold that whole assembly onto a motor. Now that motor is then going to sit over here on top of this whole contraption, wherein there is a second one of these gears to engage and disengage with it on a shaft that sits through this big U-shaped block, essentially. So there's this big U-shaped block, there's going to be a shaft here with a couple bearings. This is a good representation of that shaft, so you've got one bearing that's going to sit right here, one bearing that's going to sit right there. Your motor pinion, or the outdrive pinion, is going to sit on this shaft. This pinhole is essentially the pinhole in this shaft. Now if I could find the pin that I dropped, I would show you, but you guys are going to have to imagine it because I don't know where that went. So imagine there's a pin in that hole. That pin aligns with the slot in the gear, and thus the gear is able to slide over top of that pin while staying locked to the shaft. Does that make sense? I'm hoping that makes sense. So then that is what sits right here in this drawing and gets slid back and forth with some sort of fork that is going to ride on a shaft here. This diagram is looking at this big block of aluminum from this angle forward here. So there's going to be a fork that rides on a shaft right here that is going to fit into the groove right here on these gears and slide the one back and forth on the shaft over the pin like we were saying. This is just a cross section of the aluminum. It's going to be one big U-shaped block. It's going to look kind of something like this if you can imagine it. It's going to be kind of like a U shape on this side, but then it's going to have a big sticky outy bit, and then there's going to be another big block on the opposite side. Basically like this. This is another concept drawing I did. It's basically going to look like this, but a little bit different. Does that all make sense? I hope so. So anyway, all this is going to have to be done with the utmost precision because we're talking about tens of thousands of RPMs from our motor here. So I need to make sure that everything is spot on perfect in terms of dimensions. So the first thing I'm going to go make on Ramby, my turret lathe, is this flanged tube and this collar for turning one of these dogged gears into a pinion. Quick progress update here, guys. I've got the flanged tube here fitting very nicely into our dogged gear. It's got a hole through it to accommodate the motor shaft. And then this part here is going to become the dogged collar that is going to slip over the back of it and engage with the two notches there that you see on the back of our dogged gear. So next for me is to cut said dogs on this piece and drill a hole through both parts to fasten it to the motor shaft. So now, because I'm trying to machine such a tiny piece of metal that's round nonetheless, the problem becomes, how do I hold it? So the main way that it's going to be held, if I don't drop it, is going to be in these V-blocks here. So it's going to sit just like so. And that's all well and good, except when we go to clamp it. It starts to do that because it's so short and we need to take a fair amount off the top. So the way we combat this is by putting an offcut of the same diameter down at the bottom, like so. Now the bottom won't collapse in, and voila, just like that, we have a nice, firm clamping solution. Okay guys, it is test fit time. Here is the piece. Those are the two little dogs that we just machined. Let's see if it fits in our dogged gear here. Almost like a glove. Little love from the file, and everything is fitting together nice and tightly. It's even going to take a little tap to get it seated completely, which is perfect because I don't want this going anywhere when I'm drilling it. Fast forward a little bit and we have our two first parts of our disconnect completed, and I've got them installed on a motor here. It's looking very nice. Everything fits together absolutely gorgeously, super tight fit, especially with the fit to the motor shaft. And speaking of, I want to give this a quick test to see if there's any excessive vibration. Alright, so we're just running on 6 volts here. Feels pretty darn good, actually. Feels pretty smooth. That's a really, really good sign. I can't see any wobbling or nonsense going on with this thing. I see a little bit of wobbling in the collar, but not of the actual dogged gear on the end there. And compared to it not on there, it feels just about the same, so that's awesome. The next part I need to make is this shaft here. It sits just here in our big aluminum block. It's got the pinion on one side, it's got our dogged gear on the other, has some bearings in the middle to support it. It's going to be a fairly difficult turning process because I don't want to remove this from the lathe once so that all my shoulders are perfectly concentric to each other. So what I'll have to do is machine this out of a parent bar and then cut it out of that parent bar and check my measurements. So basically I'm not going to be able to do any test fitting of the bearings. I'm going to have to go entirely by measurement. That's going to be difficult, but let's see if we can do it. Righty-ho, here is the shaft that I have made. It did not come off the lathe this nice looking. I took some Scotch-Brite to it and polished it up a little bit. Still need to learn a bit more about feeds and speeds on the lathe and how to get nice surface finishes. But I've got some bearings, I've got a pinion, I've got our dogged gear. Let's see how all of this stuff fits. So pinion first. Does not fit. But that's a good thing. That means it's too big. We can always make things smaller. Next up is a bearing. Okay, this is nervous. This can either go great or horribly. That is also too tight. But again, that's not a bad thing necessarily. Alright, so we got 1 out of 4, guys. That was kind of underwhelming. Our dogged gear fits on the shaft very nicely. It doesn't slide super smooth, but that's because the shaft is a little bit rough, so a little more polishing up and that should take care of it. A little love with the file has our bearings sliding on super nicely. They are very tight in there, which is awesome. I've also got a flat now on the shaft for the pinion, which also fits very nicely now too. It's a tiny bit loose for my liking, but it's pretty good. I'm really happy with it. And of course, this side for our dogged gear. You'll notice I haven't drilled the hole in the shaft just yet, and I'm going to wait to do that until probably close to the very end, because I'm not quite sure where our dogged gear is really going to end up on this shaft. I also left it long just for extra wiggle room. So with that, I need to go do some measuring and draw up some plans. And a little while later, I've got a pretty good idea of how this big aluminum block is going to work. I've got some good drawings, some good dimensions that I'm confident with. So with that, it's time for me to go out and start squaring up some stock. I've got my stock all squared up nicely. As you can see, I already had a piece that was squared in this dimension perfectly, so I only had to machine 2 sides, which was nice. Next up, I'm going to machine these chamfers on the edges, which are these edges here, there, and corresponding to on the other side. Righty-ho, I've got my aluminum block nice and octagonalized, very nice and pretty there. Next up, I need to do some practice bores for our bearings, and to do that, I'm going to be using the can cycles that are in the milling machine. Now, what are can cycles? They're basically, I'm saying canned as in like canned spinach. Can cycles are essentially pre-programmed programs, or like pre-written programs that you just input a couple variables and it writes the program for you so that you don't have to do all the work. So I need to do a couple tests, not only to get our bore diameter correct, but also for me to just remember how to use the stupid things, because it's been a while and I don't want to crash anything. Guys, we got ourselves a fit. Check this out. Oh yeah, simply gorgeous, darling. Man, that is just absolutely beautiful. Such a perfect fit. So with that, let's move on and put one of those holes in our octagonal block. Oh, I fucked that up. I fucked that up. Wait, did I? Hang on, I don't know if I fucked this up or not. I have no idea if I fucked this up, guys. Let me see. I cannot see in that hole, but something tells me that is too deep. Oh, no, actually, I think we got it. Holy crap, that is awesome sauce. Yep, we're good, guys. I don't want to push that in there because I can't get it out, but that is a freaking fit. Oh, yeah. Woohoo! Next, what I need to do is drill a hole smaller than that all the way through the block because I need to. What we're doing right now is creating a shoulder for our bearings to sit on so they don't fall all the way through the hole, essentially. It'll make more sense once the whole thing is done and you can really see and understand what's going on. But we're making a shoulder, essentially, by drilling all the way through. And creating clearance for the motor little... The motor's got a little like bump out by the shaft. It's to accommodate that as well. And while I'm here, I'm also going to drill 2 mounting holes for this thing, because this is essentially the extended side of the motor. So this surface is what's going to get bolted to our motor plate. And I want to make sure that those holes line up with a standard motor configuration so that I can take this silly contraption out if I want to and bolt in a normal stock motor. Here's where I'm at. I've got the 2 bolt holes drilled and tapped there. You can see there's a shoulder down, partway down that hole. Our bearing assembly fits in there gorgeously. Needs just a little tap to get it seated down in there. It's a little bit proud, but I'll deal with that later. I don't know if it's going to be an issue or not. Hopefully not, but we'll kind of have to wait and see. As you can see, my part is starting to look a whole lot like this drawing here. My next step is to hog out a bunch of material out of the middle to make room for my dogged gears and my engagement fork. Alright, status update, yo. This thing is looking like some serious awesome sauce. So what I've done up until this point is obviously I cleared out a huge amount of material from the middle. I drilled a couple motor mount holes there because our motor is going to mount on that side, right? And then I also drilled out this hole bigger to allow for some clearance for our pinion so that I can actually recess the base of the pinion into the block like so. Now that our big aluminum block is mostly done, I might still need to make some adjustments later, but I need to start thinking about how long this shaft really needs to be and cut it down as well as drill the hole for it. And I'm actually going to chuck this back in the lathe and shorten up this little shoulder a little bit because as you can see the bearings sit just proud on the block there. I can tap it in a little bit farther, but really I just need to take off maybe 30 thousandths of that shoulder, not much. All right, a ton of progress has been made. We have a shaft with a pin through it, with a set screw in the end holding it in. Our dogged gear slides on top of that absolutely gorgeously. Look at that. That is absolute awesome sauce right there. And on top of all this, I've got my motor bolted up to our big aluminum block. Our shaft slides in absolutely gorgeously. Gotta kind of put this all together at once here. Put our dogged gear in there, push that in, and voila, look at that. This is so freaking cool. The next thing I need to think about is how I'm gonna get a shift fork or an engagement fork in here to slide this guy back and forth to engage and disengage the motor. There's going to be a shaft that runs between these 2 pieces that's going to be real nice and smooth. That'll hopefully act as a guide to guide it. But I'll have to do some thinking about that. But hey, that's tomorrow's problem. But this is super freaking cool. Check that out. Oh my gosh, I can't get over it. I can't get over it, guys. It's just so awesome. So we haven't even taken a look at the Rustler yet this episode. And for those that are still kind of confused on how this is all going to work, this guy is going to sit in here. There's going to be a pinion on this shaft, and this face is going to bolt up to a motor plate that sits just behind the spur gear here. And then we should have a good amount of adjustability with the motor this far away from the gearbox to actually get a decent sized pinion on there without running into any clearance issues. Alright folks, so I decided to go with a dual rail system to hold my engagement fork. Reason being is I want that fork supported and not in contact at all with my dogged gear except for the side surfaces. Right, so say this is my gear and this is my engagement fork. I don't want it resting on top of the dogged gear, right? Because I don't need that extra friction. I only want it contacting the side surfaces to move it back and forth. I'm over here at Ramby because I'm about to cut a couple grooves in these rails for some E-clips just here on the inside of this part of the aluminum block that will keep the rails from sliding out. To cut the E-clip grooves, I'm going to be using this threading cutter. Reason being is it's got the smallest point that I have of all my tooling to cut that groove because it needs to be really, really narrow. And to line this up, I don't know if you can see, there's a mark on the shaft there next to the cutter. I think you can see it. I'm literally having to use a magnifying glass, this shitty plastic magnifying glass, to line the tip of my cutter up with that mark, because that mark is exactly where the E-clip needs to be, or at least where the outer edge of the groove needs to be. Let's give it a whirl. I've already set my depth to the inside of this groove here on the end of the shaft, so hopefully if I just go into 0, you should be good. Let's give it a whirl. There's our little groove. Let me go grab an E-clip and see if it will fit on there. It doesn't quite snap on like I'd like it. I think it needs to be a little bit deeper or maybe a little bit wider. I'm gonna try making it a little bit wider instead of deeper, and we'll see how that goes. No, not on the floor. Oh, where did you go? Oh, it's dark down here. I can't see anything, guys. This is bad. This is bad. I don't know where my E-clip went. No! Look at me go, dropping shit on the floor. I have no idea where that went. I'm gonna go grab another one. Let's see if second time's a charm here. Oh, that is gorgeous. Oh, that is absolutely perfect, guys. Yes. Heck yeah. All right. I'm going to do the other shaft, and then that should be good to go for the rails. Boy, never did I think I would actually be using E-clips in a build, guys. That is something else. This thing is looking super trick. I went ahead and cut off the excess rail, and now I've got to brainstorm how to make the engagement for it. That's going to be a tricky one. There you go, guys. There is my shift fork. It's looking awesome. It's only about 75% of the way done. Reason being is I want to leave some extra material here for when we hook up the servo, which is going to be next episode. So I don't want to cut myself short anywhere. So I'm going to leave it as is for right now. Check that out, guys. That is freaking incredible. It is so smooth. I had to oversize these holes just a little bit. Not too much though, and it slides super nice and smooth. Spins perfectly, no binding whatsoever. Definitely by far the most complicated little device that I have ever built, but it is incredible. Now we can't finish this episode out without actually putting some power to this and trying this with the motor running. So I will meet you guys in my room. Check that out, guys. That is so cool. Really all it needs to do is disengage under power, which, when disengage, perfect. That is so cool. That is so cool. I can't believe that this more or less works, guys. That is unbelievable. I guess this is a good time to bring up, how are these bearings going to stay in the block, right? Well, my plan, I think, is just to have the motor plate be what holds them in. I think that's just going to be the best scenario instead of trying to do a screw or some sort of cover plate. I think that's just going to be the best. With that, folks, the craziest contraption I have ever made, the most precise, ridiculous, outrageous contraption I've ever made is finally complete. It's been over a year in my mind and it's finally come to fruition. This is just so incredible to see. I know this has been a very tech-heavy episode and probably kind of long too, but next time we will get on to actually working on the Rustler, making some battery mounts, making a motor mount, servo mounts, all that good stuff is going to be next time in episode 3. So make sure you tune in for that. And if you enjoyed what you saw today, please do leave a big fat thumbs up. Go down, hit that subscribe button, leave a comment down below. And if you want to support me in what I do and other crazy things just like this, consider becoming a channel member or joining my Patreon. If you want to keep up with me and other things I'm working on, my Instagram's a great place for that. Highway49_RC is my tag. And if you want to chat with me and other fellow RC enthusiasts, Discord is a great place to do that. Links are all in the description. That's it for me, guys. Thank you so much again for watching, and I will see you all in the next one.